To solve this today's LeetCode problem, this is maximum total importance of roads. You are given an integer n denoting the number of cities in a country. The cities are numbered from 0 to n minus 1. So you are also given an 2D integer array roads where road size is equals to ai, comma bi denotes there that there exists a bidirectional road connecting cities ai and bi. Right. So you need to assign each city with an integer value from 1 to n, where each value can only be used once. The importance of a road is then defined as the sum of the values of the two cities it connects. Return the maximum total importance of all roads possible after assigning the values optimally. So basically, we have given a graph type structure, and which denoted whose node denotes cities and edges is the road, right, between connecting between the two cities. So and it's also bidirectional, right? So uh, nodes is cities, edges is connections, connecting two roads, right? Connecting two roads, and it's a undirected graph, right? It's an undirected edge. Okay, so basically uh, we need to find the maximum total importance of all roads possible after assigning the values optimally. So what is the total importance? So importance here is defined as the importance of a road is defined as the sum of the values of the two cities it connects. So now basically we need to find the maximum total importance of all roads, right? So for finding the maximum total importance of all roads, so if we see the example here, n is equals to 5 and roads. So what the example is telling that how we will calculate the total importance of all roads. So basically it basically we need to assign the numbers from 1 to n to each node, and then we will just add the nodes the nodes the num we will just add the numbers which we have assigned to each node, right? To each node according to ages, right? So just that was we need to do. So if you see here in this, in the first example, so here 0 1 2 3 4 is given assigned 1 2 3 4 5 6, right? And this is how we have assigned, and now we just need to calculate on the basis of age. So first age is 0 1. So if 0 1 is connected, then we will add 2 and 4 number which is assigned to the 0 and 1 node. So 2 plus 4 is 6. Same for 1 and 2. 4 plus 5 is 9. Same for 2 3, which is 5 plus 3, which is 8. And same for 0 2, which is again 2 plus 5. And this is how we will calculate the all the summation of the numbers which you have assigned according to ages. And then after all, complete add 6 9 8 7 6, and that comes 43, right? So basically we need to maximize the summation after maximize the summation uh, by the summation of ages, right? Basically that's the meaning. So this is weighted nodes, or if you see, after assigning this is called there is a term weighted node and weighted edges. So in graph there is term weighted node and weighted edges. The term is that if a number is assigned to age or a node, then it's called weighted node. And if a number is assigned to ages, it called weight ages, right? So basically the terms you just need to know, right, about the weighted node and weighted age. So how we will maximize this, right? How we will maximize this? So if you observe here one thing, if you observe one thing if you observe one thing, that the ages, see, this 0 is connected to this 1 and 2. So this 0 numbers, which is 2, is added two times here 1, and this is 2 2 5, right? If i write this here if i write this here if you we observe something, that the number of times, the number of ages a node is connected, it is added that number of times, right? See, this 0 1 is connected, this 0 is connected to 1 edge 0 1, and this 0 is also connected to 2, right? 0 is connected to 1 and 2. So it means this zero will this zero number will occur two times in the summation, right? This zero is occurring two times, one here, two, and the second is here with two, right? Zero is occurring two times with one node and this two node. So two is occurs two times in the summation, right? And the final summation value is 43, right? So basically the number of nodes, the node which is connected to max number of edges, to max number of nodes, it will definitely contribute more number of more time, they contribute much times greater it will definitely contribute that number of times in summation, in summation, right? In final summation, that for sure, that for sure, right? That for sure. If this node, if you see this two node, this two is connected to 1, 4, and 3, it means two will definitely comes three times. Two node will come definitely comes three times. So two here assigned five. So five will come three times in this summation, right? Five will assign three times in this summation. So basically, if you see, this zero is how many times occurs? This zero is connected to one, two. This one is connected to two and three. This two is connected to uh, this two is connected to one, 1, 3, and 4, and this 3 is connected to 1 and 2, and 4 is connected to 2 only, right? This is the condition. So it means 0 is connected to 2 times. It means 0 summation contribution is uh, 2 times, right? One for 0 2, one for 0 1. So basically 2 plus 2. Again, the one contribution is 2 3. It means one contribution is 2 times. So 2 3, which is assigned 4 value. I'm not telling you to assign right now, that how we'll assign we will see further, but I'm just uh, trying to visualize you that how this is working, right? So one is assigned two times, so one value is assigned four, so we will the four times two times four will occur. Two connected to three nodes, so two values will occur three times, right? Same for 3, which is 1 and 2, we occurred 3 times, right? Again for 4, this is 1. So basically, this is how the total summation, if you add this all, it will comes to 43, right? It will comes to 43. This is how the all nodes contribution is final in this summation value, right? Final in this summation value. So basically, I'm sure about that. I'm confirmed about that. That the node which is connected to edges is contributing that much time. So it means that the number of times the node is connected to edges will contribute that number of times in my final answer, right? So I'm sure about that. That node which is connected to max number of nodes definitely contribute that number of times in final summation. So basically, now the question is the question is the question is, how will we assign the number from 1 to n to each node given, right? How we will assign that? So I think you have got till now that the number, the number, the node which is which has which has max number of edges, max number of edges, that will that should have that must have greater value assigned, must have greater value assigned, right? Then we will only maximize the total summation, right? The node which has max number of edges must have greater value assigned. Then only we will get the max summation, right? I am sure about that. So that's the only two conception, or that's only the two logic we need to know, that think that the node which is connected to the maximum edges must assign the max summation. That's the only logic we need to know. But how we will see that? So basically, now the question is just basically is now the question is just that we need to assign the nodes according to the number of edges it had. Number of edges it has. Now the question is just, so if you consider it like an array, you just need to assign, suppose it is an array 0 1 2 4 3, right? 0 2 1 3 4, this is node, and some values assigned to him like 2 3 2 1 4 0 1, not 0 1 and 2 again. So this is edges, number of edges it has. This is what I said, right? So if you see like that, we need to just assign the values to this according to edges, right? According to edges, we just need to assign from 1 to n. From 1 to n distinct numbers, assign these two nodes according to this age, right? According to this, just the question is just now. So you know how to solve this, right? We just need to, we just need to sort the vertices according to ages, right? We will just sort it according to ages, right? After sorting, what it will become? So if you sort it according to ages, first node will become 2, then 3, then 1 or 4, and then 0, right? Right, if you sort it like this according to age, right? According to age, if you sort after sorting, right? This will be after sorting. So that's the same thing we will do for this, right? Now, but how we will implement for this graph on, this is just for array, right? How we will implement this graph? So what we will do, we will calculate the number of times it has in my roadmap, number of times it has. So basically it's a in degree, right? In degree, it means that the ages which coming to towards nodes, right? Ages means which the ages which is coming towards nodes. So we will just calculate the number of times it has in rows, and we will sort it according to that and assign the numbers to them. So after this sorting, this is the vertex. Now we can simply assign the numbers from 1 to n, which will be 1 2 3 4 and 5, right? This is how we will assign that. Now now how we will take summation of this, how we will take summation of this. So I told you that how many times this age is present, that much time this contribution will occur. So this one will occurs one time, this two will occur one time, this three will occur two times, because it has two ages. It means this will contribute two times three, which is six, right? So that's how this one plus two plus three plus three, because this is occurring two times. Now four plus four, and this is five plus five plus five. This is the total summation. And if you calculate, this is the same thing which is written here, right? uh, okay, we have it's the same thing when we assign according to the value, because I have taken random edges. So that's the whole thing we need to see, right? That's the same thing. So we will just see how we will implement that. And but logic is the same, that we need to just calculate the number of edges for each node, and according to that, according to ages, we will assign the number from 1 to n and calculate on the basis of times it occurs, like that's the whole things we will do here. Just implement it and you will got that. So basically it can be long because the constraints are very high. So we will define a macro here to save our time, of course. So type def long alert. So basically it's type def, right? So one thing what we need to calculate the count of each and every. So I will take an in degree, and first I need to calculate the number of roads which we have, right? So n is the n denotes the number of cities in country, and this road is number of ages. So still to make differentiation, I will take m, it as m, and this I will take it as m, right? So it has started from 0 to n minus 1, right? The cities are numbered from 0 to n minus 1. And if I see the road's length, it is equals to 1 to 2 1 to 5 to 10 power 4, right? Basically, so n is the number of nodes, m is road dot size. So we assign the number of nodes comma 0, right? And we will move in this road to calculate the number of vertices each node have, right? So r0 plus plus and in degree r1 plus plus. So what it will do, it will just calculate the number of nodes, number of edges a particular node has, right? So n is number of vertices. So this 0 1 will calculate one times, one will calculate one time, so this will just calculate the number of edges each node have, right? Now what we will do, we will just sort it according to number of edges it had, right? So we will just sort it according to n degrees after assigning it, right? Now I will start from 0 node and go to n node, and what I will do, I will just assign the number from 1 to n. I will assign the number from 1 to n to each node according to the number of edges it had. Less number of edge, less number we assign. More number of edge, more number we assign, to find, to calculate the maximum number of summation, right? So if you see here one thing, that I need to calculate the summation, so I will take a summation. Also I need to take a count to assign my values count, right? So what I will do, I will just increment it, and I will just check in degree I. So what this n degree will do, this n degree will tell me that how much times this number is occurring, this how much times this number will occur in my final summation. This n degree will tell me the number of times, and this cnt will tell me the number which I am assigning to this. And after assigning to each number, I will increase my count, because I need to assign different number of uh, values to different number of nodes. So that would, this is how we can do. And and after all, this n degree I is, this n degree I into cnt is can be very large, and which can be out of bound. So I will need to typecast this to long to satisfy my out of conditions, and at last I will just return answer, right? So this is how we will solve this. Now the thing is, you can, we don't need to use cnt also here, right? We can just use I plus 1, because we have started from the lower point, and basically it is starting from 1 only, and all according to this I, the cnt is also increasing. So instead of using this count, you can just write it as I plus 1, right? I plus 1 instead of this. We don't need this, right? You can also write like this, right? So basically it's just like a implementation, how you implement it. So we just need to run this and check whether we are correct at correct position or not. Yes, sample case passed. Let's just submit it. So we passed all the cases, and yeah, bingo. So what the time and the space complexity? So time complexity would be, so basically first thing is to calculate all the insert all the nodes in my arrays to calculate number of edges. So that will take O of m, if where m is the number of edges it present in rows. And after that, I'm shorting it on the number of edges to whole of nodes. So the size of n degrees n, so that would take n log n. So plus O of n log n. So basically it is O of m plus n log n, and I'm not doing anything else extra. Again, I'm iterating in whole of n, that would take O of n again, right? So basically ultimately it is, you can tell that this is O of m plus n log n. That's the whole time complexity. And what the space complexity? So we have taken an extra in degree to store all the counts of nodes present in edges. So that will take O of n. And in C++, sorting takes O of one space with no, and but in some places it's written O of log n, but it's a hybrid total, right? It's total a hybrid. So O of one, I am considering O of one here, so that will be definitely O of one, right? So this is the time and the space complexity for this problem. Hope you liked it, understand it. Basically, it's a very simple problem if you just observe. So hope you liked it. Thank you so much. Bye bye. Bye bye. Right?